Imagine standing on the southern tip of Spain, gazing across just 13 kilometers of water at Morocco. Two continents so close, yet never connected by bridge or tunnel. The Strait of Gibraltar, one of the most strategic waterways in the world, hides a deadly secret. Despite decades of ambition and cutting-edge technology, why has no one conquered this modest span? The answer lies deep beneath the waters and within the complex history of two continents that, while geographically close, remain separated by more than just the sea. The strait is a crossroads of civilizations, and its waters have seen empires rise and fall. Yet the challenge of connecting these lands has proven to be an engineering and political puzzle of epic proportions. In this video, we'll uncover the mysteries, challenges, and the incredible ambition that have kept this project in the realm of dreams rather than reality. From the depths of the seabed to the heights of political negotiations, the story of the Strait of Gibraltar is one of perseverance, innovation, and the relentless pursuit of progress. Over the years, countless ambitious proposals have emerged, each one promising to link these two continents in a transformative way. Engineers and visionaries have long been captivated by the idea of a physical connection between Europe and Africa. The potential economic benefits are staggering: streamlined trade, boosted tourism, and a powerful symbol of unity. Imagine the ease of transporting goods directly from Africa's booming markets into Europe's economic heart, or the cultural exchange that could thrive with just a short drive across a bridge. The dream of a Europe-Africa connection is not just about infrastructure. It's about bridging cultures, economies, and people. Yet, despite all our modern technology and the countless megastructures built around the world, why does this modest span remain unconquered? The Strait of Gibraltar, with all its strategic importance, remains a daunting challenge. The waters here have become a metaphorical moat, protecting the uniqueness of both continents while challenging the ingenuity of humankind. What are the real barriers that prevent Europe and Africa from being connected by road or rail? Today, we will explore these barriers in depth, peeling back the layers of history, politics, and engineering that have kept this dream at bay. The Strait of Gibraltar is not just a narrow strip of water. It's a crucial juncture where the Mediterranean Sea meets the Atlantic Ocean. It's also one of the busiest maritime routes in the world, with over 100,000 ships passing through each year. Picture this: every day, a steady stream of colossal cargo ships, oil tankers, and naval vessels navigate these waters, making it one of the most vital arteries for global trade. The significance of this strait dates back to ancient times. The Greeks and Romans referred to it as the Pillars of Hercules, marking the edge of the known world. This tiny stretch of water has been a gateway for explorers, traders, and conquerors alike. It has witnessed the flow of goods, ideas, and cultures across centuries, shaping the history of Europe and Africa alike. Its strategic importance continues to this day. Control of the strait has been a coveted prize for empires and nations, and its waters have been the site of countless naval battles and trade negotiations. The idea of a physical connection between Europe and Africa has long been seen as not only a marvel of engineering, but a symbol of unity, linking two continents with deep historical ties. But as we'll see, this dream has proven elusive, tangled in the complexities of politics, economics, and geography. Historically, the concept of a transport link between Spain and Morocco dates back to ancient times. The Greeks and Romans dreamed of such connections, but it wasn't until the 20th century that serious plans began to take shape. In the 1930s, proposals ranging from monumental bridges to cutting-edge underwater tunnels were put forth. These ambitious designs were more than just sketches. They symbolized a vision of a future where Europe and Africa would be seamlessly connected, with cultures, economies, and peoples merging in new ways. Each plan was a bold statement of human ingenuity, envisioning a world where the barriers of nature could be overcome by the sheer force of will and creativity. But each time, the plans were shelved due to technological limitations, political discord, or financial constraints. It's fascinating to think how close some of these projects came to realization. Some were even backed by prominent leaders and governments, only to be abandoned as the realities of the task became apparent. In the 1970s, the Euromed transport project rekindled hopes of building a link, but once again it fell through. Each subsequent decade saw new proposals, from floating bridges to underwater tunnels. Some were visionary, like the idea of a bridge supported by giant pylons or a tunnel resting on the seabed. Each was hailed as a breakthrough, yet all faced insurmountable obstacles, reminding us of the incredible complexity of such an endeavor. The dream of connecting Europe and Africa has always been just out of reach, tantalizingly close, yet impossibly distant. Let's dive into the primary physical challenges, starting with the depth of the Strait of Gibraltar. At its narrowest point, the water is about 365 meters deep. That's nearly the height of the Empire State Building. Imagine trying to build a bridge over a chasm that deep. The foundations would need to be massive to support such a structure. Engineers would have to sink pylons deep into the seabed, which is no simple task. The seabed here is composed of unstable quaternary clay channels, which are soft and shifting, making it extremely difficult to secure anything solid. These aren't just ordinary clay. They are like a thick, murky soup that can swallow construction equipment whole. The technology required to build such a structure is still evolving, and even with modern advancements, securing stable footing at such depths remains an elusive goal. Even the most sophisticated drilling and anchoring techniques struggle in these conditions, leading to the realization that this is no ordinary engineering challenge. The depth of the strait is not just a physical obstacle. It's a symbol of the depths of human ambition and the lengths to which we must go to achieve the seemingly impossible. The challenges of building in such an environment are compounded by the need for innovative materials, precise calculations, and the constant battle against the forces of nature. Next, consider the powerful currents. The Strait of Gibraltar acts as a natural funnel between the Atlantic and the Mediterranean. Water flows in from the Atlantic at a tremendous rate, replenishing the Mediterranean, which loses water to evaporation. These currents, along with tides, make any underwater construction incredibly challenging. The force of these currents is such that they would constantly batter any structure, potentially weakening it over time. Picture the relentless force of nature working against every piece of machinery, every bolt and beam, day and night. The strait is a place where the natural world exerts its power, reminding us that even the most advanced technology must contend with the raw force of the elements. And then there are the shipping lanes. Over 100,000 ships pass through the strait each year, and these aren't small vessels. We're talking massive cargo ships and oil tankers. Any bridge would need to be high enough to allow these giants to pass underneath, meaning a height of at least 100 meters above the water. This would make the bridge one of the tallest ever constructed, adding another layer of complexity to the project. The scale of such a bridge would be unparalleled, a true wonder of the modern world, but the risks are just as monumental. The challenge is not just to build a bridge or tunnel, but to create a structure that can withstand the test of time, the forces of nature, and the relentless demands of global trade. Adding to the complexity is the fact that the Strait of Gibraltar lies on a tectonic plate boundary. The Eurasian and African plates meet right under the strait, making this area prone to earthquakes. The 1755 Lisbon earthquake, which had an estimated magnitude of 8.5 to 9.0, caused widespread destruction across the region. Any bridge or tunnel would need to be designed to withstand such seismic activity, adding further to the engineering challenges and costs. Earthquake-proof structures require advanced materials and design techniques, which are not only expensive, but also still developing. Beyond the physical challenges, there are significant political and financial obstacles. the political relationship between Spain and Morocco is fraught with historical tensions. Disputes over territories such as Ceuta and Melilla complicate cooperation. Gibraltar, controlled by the UK, adds another layer of complexity. The financial aspect also cannot be overlooked, with estimates for such a project ranging from $5 billion to $20 billion. The economic benefits, while potentially substantial, are not guaranteed, and the question remains, who would foot the bill for such an unprecedented project? The political landscape is as challenging as the physical one, with the strait acting as a dividing line, not just between continents, but between cultures, histories, and ambitions. The dream of a Europe-Africa connection is not just an engineering challenge, it's a diplomatic one, requiring unprecedented cooperation and vision from all involved. Despite all these challenges, the dream of connecting Europe and Africa with a bridge or tunnel remains an epic tale of ambition, challenges, and potential. Advances in engineering and technology may one day make this project feasible. Political landscapes can change, paving the way for better cooperation. There is even a potential $25 billion plan in place, aiming to bridge the gap. But as with all grand endeavors, it faces a mountain of challenges before becoming a reality. Whether or not it becomes a reality remains to be seen. We'd love to hear your thoughts on this one. Let us know if you think there's a solution to this complex construction problem. If you enjoyed this video, don't forget to like, subscribe, comment, and turn on notifications for more fascinating insights.